In 9709 paper 3, the separations of variables in differential equations is simple, but most students still lose marks on it. Not because they can't separate, but because they don't recognize what kind of integration they're dealing with. Different forms lead to different integrals, and if you miss that, the whole question falls apart. So in this video, I'm going to show you a few types you need to recognize and the exact integration each one leads to. Before I start, I've listed out the questions that I'm going to be solving today. You can try them out yourself before you watch me do it. Trigonometry question, and keeping in mind that we want to separate the variables, we have to also keep in mind that dy and dx have to both be in the numerator. So separate them such that dy and dx are in the numerator. So what I'm going to do is I'm going to keep dy on the left and dx on the right. And then if I had to put all the x terms on the right using algebra, it would be 1 by cos x with a sin x on top over here. And then the y would be down here in the denominator. So the thing about differential equations is that they don't tell you what method of integration to use when you're integrating after separating the variables. So what do? I've made a little list here. So you first check for the formula if it's available in MF19, and if not, is there a modified version of the formula, meaning has the x been replaced by ax plus b? If that is not available, then you want to check for partial fractions, and failing which you want to check for substitution. Now, how do you know an integration is a substitution worthy integration? You need to have the function itself in the denominator and its differential or its partial differential in the numerator, or a function and its differential or partial differential are multiplied together. This is the hint that it's good for substitution. And finally, if all of these methods fail, then we think about integration by parts. So if I'm going to integrate both sides, which is the next step, so integral of dy by y and integral of sin x over 1 minus cos x dx. For the first one, 1 by y, we know there's a formula for it, which is integral of 1 by x dx is ln modulus x. So since we know that, this is with respect to y, so it's ln y equals, and now we want to think about the right hand side. So the right hand side, typically, if you have a sine function and a cos function together under an integral sign, it's probably a substitution question, whether sine and cos are multiplied or sine and cos are divided, because sine and cos are differentials of each other, which is the condition for substitution. So if it's a fraction with sine and cos in it, we take the denominator as u. So I'm going to put that down here. U is 1 minus cos x. And in substitution, as you probably know, the next step is always to differentiate. So du by dx is plus sine x. Now both of these are used to substitute the original equation. So sin x dx is du. This is du. And 1 minus cos x we have designated as u. So integral of u du. The substitution has simplified the equation for us, and we're going to integrate it. It becomes ln modulus u. Ln y modulus on the left, and then add a plus c. I'm also going to replace the u with 1 minus cos x. Since our integration is done, ln modulus y. The next step is to find the value of C. This is a very typical question and it's not considered very hard. It's only 6 marks. Differential equation marks go up to say 9, depending on the complexity and how much thought you're supposed to put into it. So in this case, in order to find C, they've given us a value for y and x. So when x is pi, y is 4. Substitute that in and find the value of C. So ln modulus 4 is equal to ln modulus 1 minus cos pi plus C. Ln 4 I'm going to leave as is, and ln of modulus cos, you can put this in your calculator, 1 minus, and remember to use the radian feature on your calculator. So 1 minus cos pi is going to give me 1 plus 1 plus C. And since 4 and 1 plus 1 are both positive numbers, it's just going to be, just move that up, ln 4 plus ln 2 is equal to C, and C is equal to, combining the two ln expressions, ln 4 by 2 using the division rule, you get ln 2. Right? So now you want to replace it into the equation that we got. So ln modulus y is equal to, sorry, we need to replace it into this equation. Ln modulus y is equal to ln modulus 1 minus cos x, and then we're putting in the value of C, so plus ln 2. I'm just going to check what the question says next. So there are usually several parts to a differential equation, all of which carry a bit of marks. So there is separate the variables, then there is integrate. So each side you have to figure out how to integrate. Then you have to find the value of C. And finally, it says something like obtaining an expression for y in terms of x. So you have to rearrange the equation and present the answer in the correct format. So in this case, we need y to be the subject of the formula. So even though this equation is correct, we have to rearrange it such that y becomes the subject. So in this case, each of the expressions is ln. So on the right hand side, we're going to combine both the ln functions. So it becomes ln 1 minus cos x by, sorry, not by, 1 minus cos x into 2. Right? And then you want to make y the subject. In this case, you can just equate the two terms. So because there's a single log on each side, so y is equal to 2 times 1 minus cos x. And that's your final answer. The next question that I've chosen is dy by dx is equal to e to the power of 3y sine squared 2x. I chose it because of the sine squared 2x. Now, this is integral that people don't often know how to do. And I've actually done a separate video. It's called Why You're Losing Marks in Integration. Check it out. It has a lot of integrals that you're sort of expected to know, but there's no hint given in the paper as to how to carry it out. So you kind of have to learn them up and work with them so that you recognize them when you're writing your paper. Now, this question is a 7 marker, and that is partly to do with the fact that they expect you to know how to integrate sine squared 2x. So I'm going to go ahead and separate the variables. As always, dy and dx have to be in the numerator, and everything else separated according to that. So If I had to take e to the power of 3y to the left side, it would be in the denominator. And sine squared 2x remains in the numerator on the right hand side. Now it's set up for integration, so we integrate both sides, and using the rules I mentioned in the previous question, we have to decide what type of integration to carry out on these. So e to the power of 3y, we know that we have an integral for e to the power of x. So in this case, for this, we just take the e to the power of 3y, make it a negative exponent and take it up to the numerator. And that way we've set it up for integration. For the right-hand side, we have to integrate sine squared 2x. We use an identity that's available in our formula sheets. The identity is cos A is equal to 1 minus, cos 2A is equal to 1 minus 2 cos squared A. Right. Sorry, wrong identity. Cos 2A is equal to 1 minus 2 sine squared A. So we have a sine squared 2x. It's not a sine squared x. So basically we'll be using cos 4x is equal to 1 minus 2 sine squared 2x. This is the formula we're going to use. If I made sine squared 2x as the formula, I would be able to replace. So sine squared 2x is equal to 1 minus cos 4x by 2. So that's what I'm going to do here. I'm going to replace this, and I'm going to split it up into two terms. So half minus cos 4x the whole by 2 dx. Now it's pretty clear and easy to integrate this. So the left hand side, the integral of e to the power of minus 3y is e to the power of minus 3y divided by the coefficient of y, which is negative 3. That's equal to half becomes half x, and minus cos 4x by 2. I'm going to take the 1 by 2 out, and cos 4x integrates to become sine 4x. And you have to also remember to divide by the coefficient of x. So divide by 4. And then we add a plus c, always. Right. I'm going to simplify it a little bit. So negative e to the power of negative 3y by 3 is equal to half x. And this becomes minus 1 by 8 sine 4x plus c. The next step, as always, is to find the value of c using y equal to 0 and x equal to 0. That's given to us. So when x is 0, y is 0. I'm going to replace those values here. So we get minus e to the power of 0 by 3 is equal to 0 minus 1/8 of sine 0 PC. So that gives us negative 1 by 3, because e to the power of 0 is 1, is equal to negative 1 by 8. Sine of 0 is 0. Let's see. So basically c is negative 1 by 3, which we then replace in the original equation. So the original equation is right here. I'm going to replace c is equal to negative 1 by 3. So a negative e to the power of negative 3y by 3 is equal to half of x minus 1 by 8 sine 4x negative 1 by 3. Right, I just want to check if there are any other parts to this question. it says solve the differential equation and find the value of y when x is equal to half. So that we can do now. If x is half, what is y? So negative e to the power of minus 3y by 3 is equal to half into half minus 1 by 8 sine 2 minus by 3. So I'm just going to rearrange that. Negative e to the power of minus 3y by 3 is equal to 1/4 minus 1/3 minus 1/8 of sine 2. I'm going to continue the question here. So negative e to the power of negative 3y by 3. I fed the right hand side into my calculator and I got negative 0.1967. So e to the power of negative 3y is equal to negative 3 into negative 0.197, which is 0.591. Apply logs on both sides, so you'll get negative 3y ln e is equal to ln 0.591, and then you get y. Ln e is 1, so we get y is equal to ln 0.591 by negative 3, which is 0.175. And that's the answer they're looking for. The third question I wanted to try is this one, which asks us to set up and solve a differential equation. So if you look here, it says set up and solve a differential equation. Find the equation of the curve expressing y in terms of x. Now the information they've given us is that a certain curve is such that its gradient at a point xy is proportional to y over x root x. Okay, so this first section here, we need to write it down as an equation. So gradient, that's dy by dx, is proportional to y over x root x. Okay, if I want to change the proportional sign to an equal sign, we do it like this: dy by dx equals, and then you include a constant of proportionality. We'll call it k, y by x root x. This is how you convert a proportional sign into an equal sign. Right, so this is the differential equation, and now so they said set it up, which we did, and now we are going to solve it. So to solve it, as usual, we separate the variables, all the x's on one side and the y's on the other side, keeping in mind that dy and dx have to each be in the numerator. So I'm going to rewrite this as dy by y is equal to k by x root x dx. And then we're going to integrate it. So we have to consider what method of integration to use for each side. On the left hand, we have 1 by y, which is log y, log mod y. And on the right hand side, you have some x terms, but they are in the denominator. So typically, and k is a constant, you can take k outside the integration sign and bring the x terms up. So x root x is x to the power of 3 by 2. If we bring it to the numerator, it becomes x to the power of negative 3 by 2 dx. So the integration now looks simple enough. On the left hand, it is a log of mod y, and on the right hand, it is k x to the power of negative half over negative half plus c, which we can rewrite as negative 2k x to the power of negative half plus c. So what happens here is that you have two unknowns. You have a k and you have a c, and to solve for k and c, they have given us 2 points on the curve, 1, 1 and 4e. So we can use that. Substituting 1, 1, we get log 1 is equal to negative 2k 1 to the power of negative half plus c. Log 1 is 0. And 1 to the power of anything is 1. So negative 2k plus c. And this implies that c is 2k. Okay, that's the relationship between c and k. Now we'll make the second substitution, which is the point 4, e. Okay, so it becomes log of e is equal to negative 2k 4 to the power of negative half plus c. We've substituted into this equation again. Log of e is 1. You can check that on your calculators. It's something you should know anyway. And minus 2k, and this is going to be 4 to the power of negative half is 1 by 2 plus c. 2's cancel. So we get c is equal to plus 1, which is 1 plus, sorry, not 1 plus 1, 1 plus k. C is equal to 1 plus k. Okay, that's our second equation. So now we have two equations with c and k. We just solve them as simultaneous equations. I'm replacing c here with 2k. So 2k is equal to 1 plus k. K is equal to 1. And c is 2k, which is 2. So once you have the values of c and k, we replace them in our original equation. So log mod y is equal to negative 2. K has a value of 1. So just 2 x to the power of minus half plus c, which is plus 2. Then we want to check what else they've asked us to do. So we've set up the equation, we've solved the differential equation, we found the equation of the curve by finding the values of k and c, and now we have to do the last part, which is express y in terms of x. So make y the subject. So in order to make y the subject, we can convert this into an exponential form. So e to the power of negative 2 x to the power of negative half plus 2 is equal to y. Okay, so this we can split up actually if you want to simplify it, or you could leave the answer like this as well, that's fine. You can also rewrite it as y is equal to e to the power of 2 into e to the power of negative 2 by root x. Basically, I've split up this exponent here into e to the power of 2 and e to the power of negative 2 by root x, because x to the power of negative half is 1 by root x. This next question carries 9 marks. Okay, just looking at that, it tells us that it's either going to be tedious or it's going to be tricky. So let's see when we start this equation what it's going to be like. So the differential equation is dy by dx is equal to y minus 1 over x plus 1 times x plus 3. And they've given us y is 2 when x is equal to 0. Solve the differential equation and obtain an expression for y in terms of x. Okay, the first step, as always, is to separate the variables. So keeping dy and dx in the denominator on either side of the equation, we get dy by y minus 1 is equal to 1 by x plus 1 x plus 3 dx. And then we have to integrate both sides. So integral of each side. As always, we have to figure out what type of integration method to use for each side of the equation. So on the left, we have a variation of 1 by y. So it's going to be ln of modulus y minus 1. And then you can divide by the coefficient of y, which happens to be 1. So I'm not writing it. On the right hand side, I can see immediately that there are factors in the denominator, and therefore this is a bunch of partial fractions. So partial fractions need to be split up into their corresponding the fraction has to be split up into corresponding partial fractions. So I'm just going to do that separately here. So 1 over x plus 1 times x plus 3. In terms of partial fractions, that would be a over one of the linear expressions plus b over the other. Take the LCM on the right hand side and discard the denominators, and we get a is equal to a times x plus 3. Sorry, 1 is equal to a times x plus 3 plus b times x plus 1. And then by eliminating one set of factors at a time, we can find the values of a and b. So first you put x plus 3 equal to 0. That gives us x is equal to negative 3. Substitute that into the equation. 1 is equal to a, x plus 3 is 0, plus b, 3 plus 1 is 4. Okay, so this tells us that b is 1 by 4. Similarly, put x plus 1, the second factor, equal to 0. So x is negative 1. 1 is equal to a times negative 1 plus 3 is 2 plus b into x plus 1 is 0. So a is 1 by 2. Once we have the partial fractions, we can rewrite this first of all. Okay, I'll write it in red. So 1 over x plus 1 times x plus 3 can now be written as half x plus 1 in the denominator plus 1 by 4 x plus 3 in the denominator. And we can also substitute it here. So integral of 1 by 2 x plus 1, putting a dx there, plus the second integral is 1 by 4 x plus 3 dx. Right, I'm continuing the integration down here. Okay, so just rewriting that equation, we have this equation, right? This one right here. Ln y minus 1 equals the integral of 1 by 2, 1 over 2 times x plus 1 is 1 over 2 times ln of x plus 1, the coefficient of x is 1, plus 1 by 4 times ln of x plus 3, again the coefficient of x is 1, plus c. So that's the general equation, and now we have to find the value of c by using y is equal to 2 when x is equal to 0. Okay, so when y is equal to 2, we get ln of 1 is equal to half ln of 1 again, plus 1 by 4 ln of 3 plus c. Ln of 1 is 0, so 0 is equal to 0 plus 1 by 4 ln 3 plus c, and this implies that c is negative 1 by 4 ln 3. Replace that in the equation. So I am replacing it here in this equation. So ln of y minus 1 is equal to half ln of x plus 1 plus 1/4 ln of x plus 3 minus c, so plus c, so that's minus 1 by 4 ln 3. Right. It also says the expression should be y in terms of x. So we have the differential equation. We just have to present it in the right format with x as a subject. So they're all log terms. So and y has to be the subject. So since they're all log terms, we're going to combine everything on the right hand side. So we have ln of x plus 1 to the power of half into x plus 3, so I'm combining added and subtracted logs, so x plus 3 to the power of 1/4 divided by 3 to the power of 4. This is ln of y minus 1. Right, so we can now discard the modulus and discard the logs as well. So y minus 1 is equal to x plus 1 to the power of half into x plus 3 to the power of 1/4 over 3 to the power of 4. And simplifying that further, making y the subject, we have x plus 1 to the power of half, x plus 3 to the power of 1/4 by 3 to the power of 4 plus 1. And that's the answer they're looking for. Here's the next question we want to try. It's x log x plus t dx by dt equals 0. So in this case, once again, we rearrange first so that the dx by dt is, dx by dt term is by itself on the left. And the remaining terms are on the right. So negative x log x. Now we separate the variables. So keeping in mind that both dx and dt have to be in the numerator, I'm leaving dx on the left, taking dt to the numerator on the right. and then separating the x and t such that x is on the left with the dx and t is on the right, keeping in mind that you have to follow all the algebra rules as always. So once the variables are separated, we can now integrate. So we have to figure out what type of integration on each side. So on the right, it's fairly simple. It is 1 by t. We know that the integral of this is just log t. This is based on a formula in your MF 19 plus c. So that's done. On the left-hand side, we have 1 by negative x log x. Now, usually, if I see a log x in the integration, I think of integration by parts. But in this case, the log x is in the denominator. So that makes me pause. And then I would like to go down the list of integration types. So the first one is a formula. Since these are two functions that are multiplied into each other, x and log x, the formula won't work and the modified formula won't work either. These are not partial fractions because x and log x are not factors in the traditional sense. The next thing we want to think about is substitution. Now, in substitution, we want to think about whether any of these terms are differentials of each other. So what I notice here is that log x's differential is 1 by x. And we do have a 1 by x right there. So I'm going to go with I'm going to go with substitution. I'm going to take u is equal to log x. And with substitution, you have to immediately differentiate as well. So du by dx is 1 by x. And this implies that 1 by x dx can be replaced with du. So substituting both of these into the left-hand side, I get integral of dx by x is du, but there's a negative sign. I'm just going to take it out here. So du over, and log x's substitution is u. That's an easy enough integration. So it becomes negative log u, the modulus, which is equal to whatever we got on the right hand side, which is log of mod t plus c. I'm going to replace u with log x because it is a substitution question. So negative log modulus log x is equal to log of t plus c. This is the general solution, and as always, we have to now find the particular solution by finding the value of c. So for that, they have given us x equal to e when t equals 2. X equals e, t equals 2. Substituting these two values in, we get negative log of e is equal to log 2 plus c. I have done away with the modular signs because both values are already positive. So log e we know equals 1 and log of 1 is 0. So 0 is equal to log 2 plus c, which tells us that c is negative log 2. I'm going to put that into the equation. So into this equation right here. So negative log x is equal to log t minus log 2, which is the value of c. And we just want to check the question again to see how we're supposed to present the answer, because they always have instructions for that. So an expression for x in terms of t and simplify. Right, so x has to be the subject. Right. So all of these are logs. So I'm just going to simplify the right hand side. So left hand side is negative log of log x is equal to, I'm going to combine these two. So I get log of t by 2. This anymore. Right. So now, since both are logs, so the negative sign we can take inside actually. So log of log x to the power of minus 1 is equal to log of t by 2. And now we can discard the outer logs. So log x to the power of negative 1 is equal to t by 2. Now I can write that as 1 by log x is equal to t by 2. And then log x is equal to 2 by t. And if I want the value of x, we just convert it to exponential form. So e to the power of 2 by t is equal to x. And that's our answer. Final question that I want to do has a method of variable separation that is slightly different from the previous questions. Just going to copy it down first. X squared dy by dx plus y squared plus y is equal to 0. Now in this case, what you should do is take the y terms to the other side of the equal sign. So x squared dy by dx is negative y squared negative y. And then you do a variable separation. So keeping in mind that dy and dx must always be in the numerator, using algebra, separate the variables so that the x terms are on the right. So that becomes 1 by x squared. And the y terms are on the left. And that becomes negative y squared minus y. Right, so now we want to integrate. So integrate both sides. I've already got my eye on the marks, which is 8. That's quite a bit. Now, differential equations generally do have carry a lot of marks. But 8 tells me that it's either a tricky question or it's a tedious one. And now looking at it, it seems to me like it's going to be slightly tedious because we have to now figure out what integration to do on each side of the equal sign. On the right, it's fairly clear. You can do an integral of x to the power of minus 2 dx. That gives us x to the power of minus 1 by minus 1 plus c. The right-hand side, on the other hand, is slightly tricky, but if you remember that if the denominator can be factorized, then it's probably partial fractions. So if you look in here, it is minus y plus 1 in the denominator when I factorize it. And I'm going to rewrite that as integral of minus 1 by y plus 1. Now it's clearly a integration of partial fractions. So we'll do the partial fractions separately. Negative 1 by y plus 1 splits up into partial fractions a over the first linear expression plus b over the second one. Simplifying that, we get negative 1 is equal to a times y plus 1 plus b times y. Equate each of the factors to 0. So y plus 1 is equal to 0. I get y equal to negative 1. So substituting that, minus 1 is equal to 0 minus b, which gives me b equal to 1. Now we are equating the second factor to 0. So y is equal to 0. input that. Minus 1 is equal to A into 1 plus C. That gives me A is equal to negative 1. I'm going to put it back in here. So this becomes integral of the first partial fraction, negative 1 over y dy, plus integral of the second partial fraction, 1 over y plus 1 dy. Putting all of it together, have integral of negative 1 over y dy plus integral of 1 over y plus 1 dy equals to the right hand side, which is negative x to the power of negative 1 plus c. The integral of these two is pretty simple. They are both linear expressions in the denominator, so these are log expressions. So negative ln mod y plus ln mod y plus 1 equals negative x to the power of negative 1 plus c. So this is the general solution. Now we need to work on the value of c. So to do that, they've given us x equal to 1 when y equal to 1. Using that, x equals 1, y equals 1. So that's negative ln 1 plus ln 2 equals negative 1 plus c. Ln 1 is 0, so c is equal to ln 2 plus 1. Okay, having found the value of c, we just put it back into our equation, this equation here. Negative ln mod y plus ln y plus 1 equals negative x to the power of minus 1 plus ln 2 plus 1. Question also asks us to make y the subject. So I'm combining the logs on the left hand side to make it ln of y plus 1 by y equals negative x minus x to the power minus 1 plus ln 2 plus 1. Okay, converting it to exponents in order to find the value of y. So y plus 1 by y is equal to e to the power of negative x to the power minus 1 plus ln 2 plus 1, which can be simplified to e to the power of negative x to the power minus 1 into e to the power of ln 2 into e to the power of 1. The first term remains e to the power of negative x to the power minus 1. E to the power of ln 2 is just 2. You can put that in your calculator and check. And into e. Right, now we have to make y the subject. So y plus 1 is equal to y times e to the power of minus x to the power minus 1 into e into 2. So combining both the y expressions, we get y minus y e to the power of negative x to the power minus 1 into e into 2 is equal to negative 1. Factorize to remove the y so that we can find the value of y. So 1 minus e to the power of 2 times e to the power of, just simplifying this expression here now, negative x to the power minus 1 plus 1 is equal to negative 1, and y is equal to negative 1 by 1 minus 2 e to the power of negative x to the power minus 1 plus 1. Right, so pause, go back, Solve these yourself, see how this actually sticks, and subscribe. More paper 3 coming.